Hello everyone, here is Michael and this is 3 minutes of AI. Retrieval augmentation is a technique to give more context to generative AI models. It provides them with information to solve a query better. And the retrieval comes out of corpuses, and usually we have text corpuses. This is what we mostly see today. In this video, I want to show you a bit different type of retrieval used with robots. And what you see here is a recent post on Twitter that shows a new result that is called mobility VLA. And this uses a different type of retrieval. So let's look at a short video together that gives us a short impression of what this is doing.
This is Lewis's task.
So as you can see, the robot was shown a location and this was told, the robot was told what this location is. So,
Please give me a
so now
That's a temporary. Hey, robot.
look at
Hey, robot.
the retrieval.
I'm Lewis. Can you take me to a temporary desk?
Okay, thinking with Gemini. Please give me a minute. Let's go.
Okay. And now the robot continues and brings Lewis to his desk because it knows where the desk is. And what's happening here is that this is a retrieval for positions, for navigation. You can see this in more details also in a paper we'll look at in a second. But here's a nice overview that was also posted on Twitter. So what's happening is that the robot learns in its model from a demonstration where you just walk it around and show it different landmarks, different locations that you want it to remember, and just tell it what those are. And it builds a topological graph or some retrieval corpus out of it, and is able, whenever you ask something, to retrieve positions where this is out of this corpus. And then do the planning and navigate you there, bring you there. That's the major use case. So what's happening in this paper, Mobility VLA, where you can read more about this, is that they describe how they solved this and how they built this graph. And this is coming from a technology that's called structured for motion. So if we look at this is using images and camera positions that you get from the robot to reconstruct the positions of individual points depending on how images overlap and what are neighbors. So they're also introducing vertices, that's the position in the three-dimensional space, and edges that connect it. And then they turn this into a retrieval mechanism too. And this retrieval works a bit different than the retrieval that we usually know. So even if we do image retrieval, we just get back images. In this case, we want to get back the position. And what is different here is that this is using something similar to this approach here, which does camera pose estimation or relocalization. So it's looking at an image that you show that is somewhere from this space that maybe the robot has taken before. And when you ask a question, pretty much what the model does, it figures out what is the most relevant image in what I've seen before. Just maybe giving back the index of the image. And then you can look up what's the position of this. This can be a whiteboard you want to be taken to Lewis's desk. And it just knows, okay, that's where this is. And now we can localize this and know what the position is. And to get all of this structure for motion, they're using call map. This allows you from many images to figure out what are the camera positions and what are these 3D points that make up the 3D world, because it also understands depth based on these images. So that it also knows where are landmarks, where they close, where they're in three-dimensional space. That is what it's used. The whole approach is very similar to what we've seen before with visual language maps, but the difference here is that, and that's a major thing with the Gemini models, that here this data was labeled, each individual point in the three-dimensional space was labeled with a model that looks at the image, the corresponding image, and just says, I think this object is here. So it's good with common objects like keyboards or chairs or tables, and knows, okay, this location is a table. But what if you want to give it very custom, your very own definition of what this place is, like Lewis's desk? And that becomes possible through exactly the approach that we've seen before. And Secondly, what the paper also does is then it uses the data that was collected to create simulations. And what it uses for that is neural radiance fields, something I like to work on. And neural radiance fields then allow you, based on these three-dimensional points and images that you have, to construct a model or build a model that is able to generate synthetic data. Synthetic data as in it can produce new views in this three-dimensional world and also knows the depth of these. And by that, you can create a simulated environment in which you ask the robot to roam around and build its retrieval mechanism from. So that's how you can test this by just collecting some examples or reusing video footage that was shot before. And if you want to learn more about what NeRF does, and in particular how you can create these nice ones, we'll have another video on this. This was Retrieval with robots, and I hope this gives you a bit of an insight how these nice robots work and how they can navigate by taking a corpus out of these images that is also mapped onto or annotated with locations that are camera pose estimations. As we've seen before, this is what this is using. Bye.